So we're on 4.4, real zeros of polynomial functions. Our main objectives here is to understand the factor theorem, to factor higher degree polynomials, to analyze polynomials having multiple zeros, to solve area. Hold on, guys. Now, resuming our lives. So here we go, factor theorem. So with the factor theorem, you're going to see that it's pretty straightforward. Don't be intimidated by the wording. And then just factoring in general, we are going to probably rely a lot more on using technology to help with factoring in this section. So keep that in mind. And then just solving higher degree functions. We probably won't do a lot of Descartes rules, but that's okay. So starting off with the polynomial factor theorem. So the polynomial factor theorem is just basically saying when you're given a graph, exhibit A, f of x, you're going to find the factors by finding your zeros. Okay, so first you're going to find your zeros. So I have a 0 at -7, a 0 at 2, and a 0 at 11. Once you find those zeros, yes, -7 to 11. Then your factors are always going to be the opposite of them. That's because you're asking, how did I make this 0, right? How did I end up, how is my output 0? So I have at -7, we're at x plus 7. At 2, we're at x minus 2. At 11, we're at x minus 11. Make sense? That's all the factor theorem is saying, okay? Then the factor theorem is saying that if you put it all together, that's going to make your polynomial, okay? Now, what is putting it all together? So our f of x equals your a, which is your leading coefficient, times whatever your factors are. And that's your factored form. Okay, it's your a, your leading coefficient, times your factors. So because we don't have any y values here, the only thing we know that our a has to be is what? Positive, because our right side behavior of our polynomial is going towards positive infinity, right? So the only thing we know that our a is positive. If I have values, then I actually can calculate the a. But until I have values, I cannot. How do we feel about the factor theorem? Doable? All right, are you ready to do a problem? Okay, so here we go. So we have the function f of x here, and we want to write it, we're going to find the factors and then write this as an equation. So the first thing we're going to do is identify our x-intercepts. Okay, so where are our x-intercepts? -1, 1, and 2. Agreed? So we're at -1, 0, we're at 1, 0, and we're at 2, 0. After you do that, you then are going to write them as factors. Writing them as factors is going to be the opposite sign of their zeros. So our factors are x plus 1, x minus 1, and x minus 2. Still with me? All right, the third thing we're going to do is find our a, our leading coefficient. Okay? In this case of finding our a, in order to find our a, we're going to choose a point. So you're going to choose a point x, y. I'm going to always encourage you to choose your y-intercept. Why? Because anytime you get to plug in 0 for x, you plug in 0 for x, okay? So our y-intercept is right here at what? At -2, right? So our y-intercepts are going to be using 0, -2. We're using this by plugging it into our function. So our function would be f of x equals a times x plus 1 times x minus 1 times x minus 2. Okay, so we're plugging in zeros for x and -2 for y. And that's how we're going to find our a. Does that make sense? So f of x is -2. A, we're solving for. So we have 0 plus 1 times 0 minus 1 times 0 minus 2. What does that equal? 1 times -1 times -2 equals +2. So therefore, our A equals what? What kind of 1? A equals -1, because -2 divided by 2 is -1. So now we can put it all together. So our function would be f of x equals, what's our A? And what are our factors? X plus 1, x minus 1, x minus 2. Speak. Me, anybody, everybody? So far, so good? Okay, let's keep it going. All right, here we go. So it says, given this equation, with this function, f of x equals 7x squared minus 63 halves x plus 14, find the zeros. And the zeros, 1/2, 4, can you write a complete factorization? The answer is yes, okay? If you're given all of your zeros and you're given your A, you can write your function, right? So when we look at this problem, we're going to remember that we are looking for the form f of x equals, it's your A times your factors, right? Okay, our A, what is our A? What's our leading coefficient? 7, we're given 7, right? So we're given our A. So we know that A is 7. Agreed? All right, the next thing you're looking for are your zeros. Because this is a quadratic, I should have 2 zeros. Do I have all of my zeros? Do I have both of my zeros? Yes, I do. So I can write them as factors, correct? How do you write zeros as factors? X in the opposite. So if I have 1/2, then this is x minus 1/2. If I have a positive 4, then this is going to be x minus 4. So that would be my complete factorization, but it's not complete because we don't have fractions usually in our factorization. Okay? This, the denominator, is actually the coefficient of the other. So it becomes 7, and that should be 2x minus 1 times x minus 4. And that is your complete factorization. Okay? If you did not think you did it correctly, guess what you would do to check yourself? You plug it back in. You would multiply, right? You would redistribute to see if I end up in the same thing again. So I would multiply 2x times x, 2x times -4, -1 times x, -1 times 4. Combine, then multiply everything by 7. And I should come back to this one. If I do not, what does that mean I did? Something's wrong. I did not get it correct. Still with me? Was it terrible? Not yet. We had our A and we had all of our zeros. If I have my A and my zeros, I'm golden, right? All right, let's try another one. Okay, so here we have a cubic function. Because it's cubic, I should have how many zeros? 3. Cubic is 3. I have 1, 2, and 3. I have all 3, okay? So that means I can use the rule that my factored form is my A times the factors that come from my zeros, correct? Using the factor theorem. So our f of x equals, what is our A? What is your leading coefficient? 5. Our leading coefficient is 5. And then what are our factors using the factor theorem? X plus 2, x minus 1, x minus 2. There's your complete factorization. Exactly. Because you already have the hard part done, right? Okay. All right. Let's keep going. Yes. Oh, sorry. You're good. Okay. Now, if you didn't have your zeros, then that's when you would have to go back to our factoring skills from chapter 2, where you have to do the grouping, take out your GCF, and all those good things. You could also do it with the box method. So, like, I'm just going to reiterate it since I'm waiting. You could have your 5x to the third minus 5x squared minus 20x plus 20. And remember, when you're in the box, all you're doing is GCF all around, right? What is the greatest common factor of my first row? Well, that would be 5x squared. The greatest common factor of my second row, negative 20. The greatest common factor of my first column, 5x. The greatest common factor of my, what do you call this column? Second column. I don't know why. That was not working in my brain. And it's going to be negative 5, right? Okay, so now you have your two smaller factors. You have 5x squared minus 20, and you have 5x minus 5, and you're just doing their GCF. So we have 5, which is x squared minus 4. You take out 5, and you have x minus 1, and then x squared minus 4 becomes what? Anyone knows? Difference of two squares, x minus 2 and x plus 2. And do you end up with those same zeros? If those are my factors, do those make those zeros? It all comes back together. It's also best to just divide out the 5 to begin with. I don't know why I didn't. Bless you, bless you, bless you. But again, we already had it and we didn't have to do that. So easy peasy. Just throwing that out there. If you forget the easy way. All right. Do you think this is going to change just because you get a fraction? Like a whole fraction situation? No. Still going to be the same. I just need to find my A and find my zeros. So here we go. Can we find the factored form of this? What are the two pieces of information I need? I need my A and my zeros. Do I have my A? What's my A? Negative 1/2. Do I have my zeros? Yes. So do I have everything I need in order to write it in factored form? I surely do. So f of x equals negative 1/2. And then we have and bam. How you feeling? Okay. A little, hey, there's no such thing. All right. The next example you're going to see is that you are given the equation and you have the choice. Do you want to do it by hand or do you want to find your zeros? Okay. How you find your zeros is up to you. You can find your zeros graphically, can you not? You can find your zeros by factoring, can you not? Yes. So when this, exactly. So if I'm giving this problem and I'm trying to figure out what is the factored form of this, I can use the calculator to help me find my zeros because what I already know is my A. What is my A? Negative 2. And so what I need left are my intercepts, right? I need my x-intercepts. So I'm going to go to the handy dandy calculator. Hey, Sylvie. So I go to y equals. I'm putting in negative 2x to the third minus 6x squared plus 2x plus 6. I'm going to hit graph. I'm going to let Sylvie think a little bit. Here she goes. All right. Can I easily count out where my x-intercepts are? Yay, nay? I can, right? I can see where they are. I can see that this is at -3. I can see that this is at -1. I can see this is at +1. If I couldn't see that, then that's when I would use the second trace. And remember, you can find your zeros when it's harder for you to see it, right? I can also go to the table to see if they're integers as well. So when I go to the table, I can see, okay, good. They are integers. It's not a decimal. I have a 0 at -3, a 0 at -1, and I have a 0 at 1. Do I have everything I need now to write in factored form? I do. I have that my A, sorry. We know that our A equals -2, and we know that we have x-intercepts at -3, 0, -1, 0, and at, what's it, +1. So now my factored form would be f of x equals, what's your A? -2. Using the factor theorem, what's my first factor? X plus 3, x plus 1, and x minus 1. And that would be your factored form. Thanks to the factor theorem. Questions, comments, concerns about the factor theorem? Okay. So even though in this example, all the other ones, I told you what your zeros were, right? Or I had a graph and you saw your x-intercepts. In this case, you had nothing and you had to create that for yourself. Was that terrible in its own? No, it was not. Okay. All right. Are we good? Okay. Next, we're going to talk about word problems. So when I graded y'all's last test, on the word problem, which was the last problem on the test, there was a domain restriction. And a lot of you failed to acknowledge the domain restriction, meaning that you didn't say that it had to be a positive, it had to be greater than or less than. You just wrote a number, right? You didn't acknowledge, oh, this is what this meant. Oh, I couldn't use this number. Okay. So you either, if you have the right number, you may not have gotten full credit for it because you did not write it in the right form of an answer. Does that make sense? Okay. It is very important that you pay attention to your word problems when they're giving domain restrictions. So for example, we have this polynomial function here, and it represents an insect population P in thousands per acre, X days past May 31st is approximated, okay? And so, but it tells you that this only applies from 0 to 6 days, right? So 0 days up to 6 days after May 31st. So May 31st all the way up to what? What, 6 days after May 31st? June 6th. Okay, so from May 31st to June 6th. So if you were to give me an answer for this on the test, it should be referring to a date in June. Does that make sense? Okay, because that's paying attention to what the word problem's asking of you. All right. The other thing that's really helpful is if you were given a restricted domain in your problem, it is a good idea to restrict that domain on your calculator. Therefore, you're also telling yourself, oh, don't look past that, right? Does that make sense? You're giving yourself boundaries. All right. So we're going to talk about that today as well. So for this problem, it wants to know when is it at 30,000 per acre? Okay. Remember, P is thousands per acre. So when we write this, we're looking for when does P of X equal 30? And P of X is 2x cubed minus 18x squared plus 46x. Okay. In order to use the factor theorem, this must be equal to 0. Okay. Currently, it's equal to 30. What would I need to do to make this equal to 0? Subtract 30. So when I subtract 30, I'm left with 0 equals 2x to the third minus 18x squared plus 46x minus 30. Once I'm in this form, all I have to do now is figure out when do I equal 0, right? When do I equal 0? So we go to our handy dandy calculator. Turn it on. I'm going to go over here and I'm going to type this in. So I have 2x to the third. I need to delete one of you. Yeah. You know what? I should have just cleared it. 2x to the third minus 18x squared plus 46x minus 30. Okay. Before I go look at the graph, I'm going to change my domain to fit my restrictions. So I'm going to go to window, and my x's cannot be less than 0, and it can't be greater than 6, right? Does that make sense? I'm going to put it at 7 just to give myself a little bit of room because I hate when it like stops right on the line. I'm going to go 1 above and below, but I know that that's where I'm at. So when I hit graph, anything that I see on this screen is a viable answer. Does that make sense? Because it fits the domain that was given to me. Yes. All right. So when I look at it, it also makes it easier for me to read. So I'm at 1, I'm at 3, and I'm at 5. Do we see that? So my x equals 1, x equals 3, x equals 5. What does that mean in terms of this problem? So I have an x-intercept at 1, 0, x-intercept at 3, 0, and an x-intercept at 5, 0. Okay. So what this means is that after 1 day of May 31st, which would be June 1st, right? So one answer would be June 1st. My other answer would be June 3rd. Yeah. And then my final answer would be June 5th. And that's what your answer would be. Okay. The whole purpose of a word problem is to apply it to a situation, right? And if I just say 1, 0, 3, 0, 5, 0, that's not telling you what it means for this problem. But I'm telling you on June 1st, June 3rd, and June 5th, you'll have about 30,000 bugs in your farm. Okay. All right. How do you feel? Good? Factor theorem, are cool with it? All right. So in previous units, if you weren't strong at factoring, here you go.